Thank you, Ante. I hope you can hear me. Yes, this is about change. When I joined Stora Enso 19 years ago, I joined as a mill director in France, producing graphical papers. And I thought I would have a quite professional life ahead of me. As it turned out, that was not the case. I mean, the company was really hitting the wall in 2006 as the graphical paper market went down, and we had literally to invent ourselves. Today, you see that not only in the product portfolio as we have it today, but foremost, I think we at Stora Enso, we have changed. And that is decisive. I think I'm a different person today. It's about radical ideas. It's about reinventing not only yourself, but the industry. And this is the background to bring forward this, you may call it a crazy idea. Actually, you will be the first public audience where I will present this. So it's also a test for me, it's a test for us, how relevant this can be. And I really look forward then to your input and critical questions. When I say reinvent, it meant for us, first of all, we had to reinvent, other way around, our product portfolio. So we took a fresh look at what a tree can do for us, which goes far beyond just graphical papers or making pulp. So this is what we are about. It's about renewable materials. But then we saw it's even a larger picture, which has been addressed already this morning in the panel discussion. We are part of the bioeconomy. That means it's not only about products, but it's also about resources, it's about circularity, and we also have to think about biodegradability, the waste, and the climate effects. We tried something new. We're not the only one. SCA did the same thing this year. It's a new way to really try to estimate our impact on the climate. And basically what we see, there are three factors which are important. So first of all, yes, that was brought up in the morning, the role of forests. There's a certain impact. But then, of course, we have the value chain. That means the Scope 1, Scope 2, and Scope 3 emissions. And then we have something we try to estimate. It's not yet scientific. It's simply called substitution of fossil products by our products. That means fiber-based packaging replacing plastics, or wood panels replacing fossil building materials. And we have tried for the first time to estimate this. And what you see is, yes, forests do have an impact also as zinc, but it's minor. That's statement number one. Value chain, yes, we still have some carbon emissions left. I'm happy to say I'm also responsible for the implementation of the carbon neutral roadmap at Stora Enso. We have already lots of units being carbon neutral, especially in Sweden. I have really the conviction we will drive this through until 2030. For Scope 2, yes, we make also big steps. I really hope that the Olkiluoto 3 project here in Finland will start up next year. That will help us also enormously on the Scope 2. Value chain is also Scope 3, the transports. That is then the remaining part. As also Lena said in the beginning, that is something we have to work on. It's 7 million of these 11 million tons. But the big part is the substitution effect, 21 million tons, which also means if you make the sum, in total, we believe we help to prevent global warming. Can we drive this further? Product substitution. Answer is yes. Plastics in packaging, we believe 25% of plastic can be replaced. I'm not talking about here Stora Enso, but by the whole industry within 10 years. That's a huge impact. It means if you translate it into CO2 emissions, it would be something like 18 million tons of CO2 being saved if we do this transition together as an industry. I don't want to go into detail about the wood construction. Previous speakers have done it already. Here you see one example. I completely agree with the colleagues. It's not wood or, but it's wood and. In this example, what you see here, the lighthouse in UN, so yes, you have this material mix. Wood is one part, it's an important part, but it works only in collaboration with the other sectors, means with concrete, steel and aluminum and others. We have tried to estimate what can realistically be done. Yes, I think we can triple the market share. I mean, the figures I've taken is starting from the whole construction in the whole of Europe. There currently, we have to say we're starting from a really bottom level. It's 1%. I believe in a market-driven scenario, it can be 5% in 10 years. If you translate it, it's equivalent in terms of the wood needs of one new pulp mill in Europe. And again, there's a huge impact on the CO2. Why do I make this comparison? Because I think both in the cases of plastic substitution and of the wood products, because this is a question which pops up often in Brussels. I'm asked, okay, if you do this, do we have the resources? And yes, we have checked it from the forest side. We can supply the fibers necessary to do this in the whole of Europe. But we don't stop there. So what is the next radical step? I've done with my energy team what we call a Landscape 2050 Plus study. Here I've summarized the 3 big statements. We have looked at all these fancy technologies, power to X. For our industry, and I'm pretty much sure it will not be so much about hydrogen. What I can simply say, the most simple power to X is power to steam, which means in our case, electrical boilers. That could become reality if there is enough renewable electricity and if it's cheap enough. And if they are realistic, then we're probably talking about 2050 plus. So that's the first statement. Then we have looked at carbon capture and utilization. Again, if I compare a little bit the volume and the purity of the CO2 streams, which can be separated, and then you do something about it, I would say I've looked at the chemicals industry, I've looked at the civil, it means concrete manufacturing, they have higher streams and also more pure CO2 streams. So from a symbiosis standpoint, it probably makes more sense if you think about the production of green fuels, that these investments would be done at, for instance, at fertilizer plants. A fertilizer plant, just to give you an idea, that has emissions of about 2 million tons of CO2, which is the whole of Stora Enso, all of our operations, just to put it in perspective. So there I would say CCU, good to watch what the others will do, but probably not for us in our industry. But now I come to the part which really excites me. It's CCS. In our case, and here we're different from the fossil industries, it's, in one short word, it's BECCS. It's biomass, it's biogenic CO2 being captured and stored in the ground. Carbon sinks, the need is there, that was highlighted this morning. Reducing emissions is, of course, the first priority. It's the same as with energy efficiency. So what I present now, that can only be the last resort. It's now a research area, it's a development area. We want to go this way, but saying so, it should not substitute our efforts to reduce the CO2 emissions. We take the case in Sweden. What you see here, and this is done by a consulting company which we use here. Sweden wants to become carbon neutral by 2045. They have made a scenario. There are still emissions which cannot really be abated. And this is estimated to be 5 to 10 million tons in 2045. And that is when the Swedish government has asked themselves, what can we do then? That's where the role of carbon sinks come in. So there's a need of 5 to 10 million tons to be compensated by carbon sinks. And of course, if you look at the sources in Sweden, I think we, from our industry, here we can contribute with BECCS. Not CCS, but with BECCS. Then the other way around is, how can you justify this? Because this will cost something. But again, looking from a government perspective, you have the whole array what you can do. Energy efficiency, LED lamps, solar cells, charging spots for EVs, and you see a little bit the cost for the society. And in that range, I can say BECS, yes, it does cost something. It's around 100, 120 euros per ton of CO2 being stored. But compared to the other options, it can work. We can also do it, let's do the calculation another way around. There are 10 million citizens in Sweden about, 10 million tons of CO2 to be put in the ground at 100 euros per ton. That makes 100 euros per citizen per year. And that would allow Sweden, if we believe the simulation, to become carbon neutral in 2045. And if Sweden will continue this way, and that's the ambition, it's not only to become carbon neutral as a society, but even carbon negative. So what is this carbon capture and storage? It's three parts. Separate the CO2, transport it, and then put it underground, either in oil wells or in abandoned gas fields. It can be onshore or offshore. Our study is supported by the Swedish Energy Agency. So far it's also a public study, that's why I can also openly talk about it. It will be finalized in the spring and then published in June. What we want to study is a model to remove 1 million tons of CO2 from either our Skoghall or our Skutskär production unit. We want to find the best suitable technology to remove the CO2 from the flue gases, recovery boiler, and the lime kiln. We need to know the CAPEX costs, the OPEX costs, all the way down, the transportation cost of the CO2, and then the underground storage cost. That's the goal of the study. Here you see the two sources. Don't want to explain how a pulp mill works, but you see the red arrows, flue gases at the recovery boiler and also at the lime kiln. There are currently 4 different technologies, so that's a big part of the study. It's not a completely new field. So this separation technology has been tested, interestingly, a lot in the US and in Canada to remove CO2, but for another purpose. They wanted to have the CO2, pump it underground to put even more oil out of almost depleted wells. I think what we do here is much more compatible with the ambitions of the EU. Then the next part is the local CO2 buffer sites, which is what you need to do. You need to compress the CO2 so that it becomes liquid and then can be transported. This is typically done by a partner, so it's not part of our industry. And then the part is you put it underground. There are currently already possibilities in Norway. So Equinor is on this. The principle is very simple. If you put it that deep under the sea, you have the pressure, and under this pressure, the CO2 becomes a fluid, and it stays there. And first of all, it goes where it really belongs. If you think 300 million years back, what was the Earth like? There was only life in the sea. The atmosphere of the Earth was 95% CO2 and 5% oxygen. There was no life possible. And how did it work then with nature? Basically, the CO2 went down into the water, and that is how fish and other species were built, absorbing the CO2. Now, in this situation, we have to do it with technical means, but it's basically the same process to bring the planet into an equilibrium. After doing the study, what is the next step? I mean, we're not the only one. There is currently a test installation going up the next month at the Stockholm Community Plant. This is important to really test what the study shows. That means a live test on the recovery boiler. Here you see what it looks like. Of course, it's very small. but it's necessary in our industry that before we scale it up, that we will run through a test. And then the last slide is, I mean, this is going to cost a lot, not only in terms of OPEX costs, but also of CAPEX. To make this work, that's why I'm saying it's not only a public study, but it needs also the political framework. And I just put up a couple of questions for politicians to think jointly together about it. First of all, how to qualify underground storage sites, offshore and onshore, and how to communicate this to the public. I'm from Germany, and we have seen in Germany the debate already 10 years ago. First attempt to store CO2 underground, it went completely into the wrong direction because of really, I would say, populist arguments. And that is something which has to be avoided in the debate. Second point is how to create a Europe-wide CO2 transport. Today, what is possible? Yes, I can transport the CO2 from Sweden to Norway, but this is by bilateral agreement. But I think if we do it wider, then the EU has to come up also with a Europe-wide solution. Then, of course, the best model for rewarding the carbon storage. We have already a market for the CO2 certificates to entice the reduction of CO2 emissions. I could imagine a similar model here could be run by a reverse auction or market model. And the question is, should it be member states first to try it out, maybe then later a Europe model? And then the last one is, of course, how to support the scale-up. What I've shown to you, that is already in our case, it will be a multi-million, something like 200, even 300 million euros investment. And that is something, when we're not doing this for free. When we as the industry, we want to contribute, but we're also business. So there's also a way to think about then how to support this by research programs, development programs, to bring it up to industrial scale. Last point I would like to say, of course, it will make a difference. Antti, you mentioned carbon negativity. Yes, imagine what it means. Products coming out of our Skoghall mill is packaging used in Tetra Paks. In the future, you would buy a juice, a milk, in a container which is carbon negative. Imagine what this means. You would do something good for the environment. Thank you very much.
Thank you so much, Heinz, for the exciting presentation. I remember as a teenager already asking myself the question, what is the problem? Why don't we just put that stuff in the ground? And I think you showed us the big picture of why it's still a challenge and what needs to be done to get there. And I'm really hopeful seeing that the industry is taking the first step into this direction, and hopefully we can get there. So, any questions from the audience? Yes, Peter.
Peter Meyer, Austrian Research Center for Forests. Thanks very much for the presentation. And you mentioned that there had been a debate a couple of years ago about that. So if some of your critics might say, why do you not avoid CO2? And why do you put it back? First you release it, and then you take a lot of money to put it back. So what's your answer as a company to such comments? That might be interesting to know.
Yeah, of course, we start from the forest. So basically, if you think about it, the products, they are produced from fibers coming out of the forest. So it means already that we have basically biogenic carbon. I know that the concept of biogenic, that has to be explained in simple terms. This is still a challenge when I talk to colleagues in other industries and I make that distinction between biogenic and fossil carbon. It's not that they don't agree, but it takes, I totally agree, it takes a lot of, as also the previous speakers were saying, we need to communicate this in a good way.
More questions? You have one?
When we are talking about carbon sequestration, I think it's good to to make the comparison between what you do with a tree and what you do with CCS. If you sequestrate 1 ton of carbon dioxide in a tree, you can gain between 50 and 100 euros for the product. This is only a cost. So if you can do this in a larger scale, if you can sequestrate more carbon by more growth in forestry, I think that's the first choice, and this is the second. Do you agree?
Yeah, totally agree. That's what I was trying to say in the beginning. So first of all, it's reducing the emissions. That is our first target as an industry. Growing trees, yes, but then honestly, every time I speak in Brussels about this, then the question is, yeah, do we have enough ground for this? Huh? And honestly, if you make the calculations, there is limits to the expansion of forest space. That's number one. And as Lena has rightly said, the role of the forest, and Hannele had said it also, it's not primarily as a carbon sink, but it's to make good use of the good fibers. And that is why I think if we can take this third part, that can be another game changer. And it's, once more, it's something we can do as an industry, but other industries cannot do in the same way. So the whole argumentation, what you're saying, if you do it, that was also the reason why this probably failed in Germany. This was about continuing coal power production. That was then the main argument by the ecologists, saying, if we do this, then we allow coal to be used as a fuel into the future. What I've presented here is a totally different thing. This is about carbon negativity, being part of the bioeconomy and the circular economy.
We have time for more, if there are any. If not, I have, there is one, okay.
Hi, Chartauza Senior New. You've presented a very nice table with different social costs of different technologies being implemented. But did you maybe make also not just such a linear calculation, but also comparison in terms of time and money investment of promoting, like really promoting and financing construction with wood and BCCS?
Yes, we're also looking into this. As Lena rightly said, wood construction is also carbon storing. So you store it for the building lifetime, which can be 50 years, it can be 100 years, or even more. And this is absolutely relevant. That's why I pointed it out. Because it will bring us over that hump in 2050, 2060. On the other hand, we have to a little bit think ahead. It's not only about the decades to come, but if we really want to put the planet into an equilibrium again, then to store it in wooden buildings, that is one step. But if you truly think circular, then you have to go one step further. What happens at the end of the building lifetime? How can we extend then the storage of the CO2? So there we have to put more thinking into it. There are ideas, I can tell you. Not only from our industries, that's why I was saying it's important that we together do it with other industries.
One last, if primitive question, and this comes now from the teen-aged Antti. What happens to that CEO in the ground when it's down there with the liquid? They talk now about space exploration and space junk and being sustainable when we venture into space, but do you know, are there any ideas of what happens to this liquid carbon in the long run if this becomes a mainstream technology in the ground? Are there any threats related to this?
Yeah, honestly, that's a question which is beyond my competence. So that's also an honest answer. But of course, that is one of the questions we put down in the study, as we are not competent as an industry or as Stora Enso. And yes, we will come back to an answer in June latest.
Okay, thank you. Let's give a hand. Thank you.